Hello, science fans. Welcome to another fascinating journey into the wonders of our planet's atmosphere. Today, let's unravel the mystery of the polar vortex, a name that sounds like it belongs in a superhero movie, but is actually a real and vital part of our planet's climate system. It's a phenomenon that affects weather patterns all over the world, even if you live far from the poles. The polar vortex is a massive, spinning pool of icy air high above the North and South poles, rotating counterclockwise around the Arctic. Imagine a giant, invisible whirlpool of cold air, swirling tens of thousands of feet above the ground. It's not a storm, and it doesn't swoop down to your backyard like a tornado or hurricane. You won't see it on your street, but you might feel its effects. Instead, it's a high-altitude feature that usually stays locked over the polar cap, circling the pole like a guardrail for the coldest air on Earth. The vortex has two main layers. A lower part in the troposphere, where our weather happens and where we live and breathe, and a much stronger part in the stratosphere above, where winds can reach incredible speeds, circling the pole like a jet stream on steroids. During the long, dark polar winter, the air over the Arctic gets extremely cold and dense, creating this spinning circle of frigid air. The lack of sunlight means the region loses heat, and the cold just keeps building up. The polar vortex acts as a barrier, keeping the coldest air on Earth contained at the poles, almost like a lid on a freezer. When you hear about the polar vortex causing a cold snap, it means a piece of this icy air has escaped southward, not that the vortex itself has moved. It's like a crack in the freezer door, letting the chill spill out. This happens when the vortex weakens or becomes unstable, letting Arctic air spill into North America, Europe, or Asia. Sudden stratospheric warming events or shifts in wind patterns can trigger these escapes. It's not a monster storm, but a breakdown in the atmospheric barrier that normally pens in the cold. The result? Sudden, dramatic drops in temperature and sometimes record-breaking cold spells. When that barrier falters, the cold air is free to wander, leading to some of the most extreme cold snaps we experience. That's why you might find yourself shivering in places that are usually much milder. It's all about physics, temperature, and the spin of our amazing planet, an invisible dance that shapes the weather we feel every day, no matter where we live. The polar vortex isn't a permanent fixture in our atmosphere. It grows and intensifies during the fall and winter months, then gradually fades away in spring and summer, all thanks to the changing angle and strength of the sun's rays. As the northern hemisphere tilts away from the sun, the Arctic plunges into months of darkness, known as the polar night, and temperatures plummet to extreme lows. This dramatic drop in temperature creates a huge difference between the icy poles and the relatively warmer mid-latitudes, setting the stage for the vortex to form and intensify. In the heart of winter, the vortex strengthens, spinning faster and locking frigid air over the Arctic, almost like a giant atmospheric barrier. The polar jet stream acts as a powerful fence, separating this mass of cold air from the milder regions to the south, and shaping weather patterns across continents. When spring returns, sunlight begins to warm the Arctic again. The temperature difference shrinks, and the vortex gradually weakens and loses its grip. Its spin slows, it breaks apart, and by summer, it's barely there, waiting for the next polar night to return and start the cycle again. A strong, stable vortex means the cold stays put, often leading to milder winters for much of North America and Europe, with fewer outbreaks of Arctic air. But when this seasonal rhythm is disrupted by natural variability or climate change, our winter weather can take a dramatic and unpredictable turn. The strength and stability of the vortex each year can impact billions of people, influencing everything from heating bills to travel plans. It's a fundamental rhythm of our climate, connecting the Arctic to the rest of the world in ways we're only beginning to fully understand. Sometimes, the polar vortex gets knocked off balance by powerful atmospheric waves, like a bell struck by a jolt of energy. These waves, often generated by air flowing over mountains or sharp land-sea contrasts, can disrupt the vortex, causing sudden stratospheric warming events. The polar stratosphere can warm by up to 28 degrees Celsius in days, weakening the vortex and making it wobble or even split. When the vortex splits, cold air escapes in multiple directions, one lobe over Siberia, another over North America, triggering severe cold outbreaks. The disruption high above eventually works its way down, making the jet stream wavier. These deep waves allow Arctic air to plunge south, bringing the deep freeze to millions. A wobble in the stratosphere can set off a cascade of events that chills the ground far below. The winter of 2019 showed just how powerful a polar vortex disruption can be. A sudden stratospheric warming event split the vortex, sending a lobe of Arctic air into the American Midwest and Northeast. Temperatures plunged to record lows, Chicago felt colder than Antarctica, and daily life ground to a halt. Schools closed, flights were canceled, and even the postal service stopped deliveries. Power grids strained, and frostbite became a real danger within minutes outdoors. This event was a textbook example of how a wobble high in the atmosphere can have life-threatening consequences on the ground. The polar vortex's breakdown opened a refrigerator door from the Arctic straight to the American heartland. In March 2024, scientists witnessed a rare event, the stratospheric polar vortex over the Arctic reversed direction, spinning clockwise instead of counterclockwise. This major sudden stratospheric warming with vortex reversal was one of the strongest ever recorded. Powerful atmospheric waves not only stopped the vortex but pushed it into reverse, dramatically warming the polar stratosphere. Despite its strength, the timing, late in the season, meant the impact on surface weather was muted. The sun was already returning to the Arctic, so the cold potential was fading. Still, the event led to a negative phase of the Arctic oscillation, contributing to late-season cool spells and unsettled weather. The 2024 reversal shows that timing and atmospheric conditions shape how these disruptions affect our weather. The polar vortex and the jet stream are partners in shaping our winter weather. The polar jet stream is a fast-moving river of air that acts as a fence, separating cold Arctic air from warmer regions. When the vortex is strong, the jet stream is fast and straight, keeping the cold locked up north and winters milder in places like the US Midwest. But when the vortex weakens, the jet stream slows and becomes wavy, creating deep troughs and ridges. These troughs become superhighways for Arctic air to plunge south, while ridges let warm air surge north. That's why a polar vortex event can bring record cold to one region and unusual warmth to another. The jet stream delivers the Arctic chill and sometimes a surprise warm spell. It's a tug-of-war that creates dramatic weather contrasts across the hemisphere. Not everyone feels the polar vortex's chill equally. Geography plays a big role. The US Midwest, Northeast, Eastern Canada, and Western Europe are prime targets for Arctic outbreaks. The wavy jet stream often sets up a deep trough over Central and Eastern North America, funneling cold air south. Mountain ranges like the Rockies help generate the waves that disrupt the vortex, while the Atlantic Ocean helps anchor these patterns. The Pacific Coast, by contrast, is usually spared the worst, thanks to a different jet stream path and the moderating effect of the Pacific Ocean. So, your location matters. While the Midwest shivers, Alaska might bask in a warm spell. A weakened vortex rearranges the cold, concentrating it in hot spots and bringing warmth elsewhere. It's not global cooling, it's a reshuffling of extremes. The weather lottery depends on where you are on the map. When a polar vortex event strikes, safety comes first. Dress in layers, thermal base, fleece, insulated outerwear, wool socks, hat, and mittens to trap body heat. Prepare your home seal gaps under doors and windows, hang blankets for insulation, and stock up on fuel if you have a fireplace. If a power outage is likely, fill your car's gas tank and your bathtub with water for emergencies. Choose a small, well-insulated room to keep warm if the heat goes out. Use a hot water bottle under your covers to create a pocket of warmth at night. Unplug major appliances during outages to protect them from power surges when electricity returns. Extreme cold can be life-threatening. Plan ahead, stay indoors, and check on neighbors. Limit time outside as frostbite can occur in minutes. Keep emergency supplies, food, water, flashlights, and batteries on hand. If you must drive, keep blankets and a phone charger in your car. Simple steps can make all the difference until the deep freeze passes. Stay safe and stay warm. Scientists are racing to understand how climate change will affect the polar vortex in our winters. The stakes are high, as these changes could impact everything from our daily lives to global agriculture and energy systems. The Arctic is warming much faster than the rest of the planet, shrinking the temperature difference that powers the vortex and jet stream. This rapid warming is sometimes called Arctic amplification, and it's one of the most dramatic signs of climate change. Some research suggests this could make the jet stream weaker and wavier, leading to more frequent polar vortex disruptions and extreme cold snaps, even as average winters get warmer. These disruptions can send frigid Arctic air plunging far south, catching cities off guard. It's a paradox. A warming world might bring more wild swings between warmth and deep freeze. For many, this means unpredictable winters with sudden shifts that challenge our expectations and infrastructure. But not all scientists agree. Some models predict the vortex's strength may not change much, or that other factors could offset Arctic warming. The science is still evolving, and debate continues in the research community. The interactions between the troposphere and stratosphere are complex, and climate models are still catching up. New data and improved simulations are helping scientists unravel these mysteries. What's clear is that polar vortex disruptions have become more frequent in recent decades, making headlines and affecting millions. Whether this is a temporary trend or a sign of long-term change is still unknown. Scientists are working to separate natural variability from human-driven shifts. Scientists are monitoring events like the 2019 cold snap and the 2024 reversal to refine their predictions. Each extreme event offers new clues and data points. Understanding the polar vortex is crucial for preparing for more unpredictable winters. Better forecasts can help communities, businesses, and families adapt to whatever the season brings. Science is on the case, working tirelessly to unlock the secrets of our changing winters.